In this video, I want to very briefly show you guys the source code for Shellsort. Now for this, you don't really need to spend that much time on, just have an idea, have an idea basically of how it relates to insertion sort. All right, so here right on the bottom, we have basically the boilerplate stuff we've always had, right? So less and exchange, no need to talk about that. Okay, so then we have kind of our main algorithm over here. Let's see. So I'm going to go ahead and highlight a little bit of a region here, right? This region here I've highlighted, this is insertion sort. The letters are maybe a little bit different, but the algorithm really is identical. It really is identical. All right, so starting at the top of this code, initially we have n defined, that's pretty typical, size of the array. And then we have h, right? So h is going to be our gap value, right? So that's the size of our gap when we're doing our different sorting algorithms, when we're doing our sorting. And so the first part here, right, is basically to determine h. So we want h to be at least 1/3 of n, right? We don't want it to be too big, we don't want it to be too small. If it's too small, it'll be a lot of work, right? It'll basically just be like running insertion sort. The advantage, right, is starting with gaps that are reasonably sized. That way we get to move these things that are far apart into positions that they belong. Hopefully it saves us time later on. So you want our gap to be reasonably large. And so this is basically, somehow here there's a sense of like it's this forward algorithm. It's basically saying, okay, you know what? Let's say the user has input of size, I don't know, 150. It wants to find a gap that's appropriate for that. It basically starts at 1 and builds up. So it says, okay, you know what? 1 is less than 150 divided by 3, right? So that 150 divided by 3 is of course 50, but I'll write it down. So initially I start at 1. Right, and it's like, well, that's kind of too small. Then I go basically do this code here, right? So 4, right, is my next one. 4 is still less than 1/3 of that, so I got to do it again. So 4 times 3 plus 1, 13. 13 is still less than 1/3 of 150, so I'll go to 40. 40 is still less than 1/3 of it's still less than the third of 150, so I'll go again, right? 40 times 3 plus 1. 121, all of a sudden that's greater than 1/3 of n. So then it'll terminate, right? So in this example here, if I have n equal 150, that implies that h will be 121, right? And so this code here, right? This over here, right? This is what we call the gap sequence. Right, so these are basically the different values that h will take on as your algorithm tries to do the sorting operation. But they're in reverse, right? You're kind of building upwards. You're going to destruct it in a second, but right now you're building upwards to find a good value. So you start with 120 here in this example, okay? And based on, if your input gets bigger, obviously this is going to be a bigger value as well. All right, then you have your while loop. So your while loop, right, basically is on h, so that's on your gap size. You're going to loop while your gap size is, significantly large, right? So it's larger, greater than or equal to 1, right? We want to at least get down to 1 because 1 is just insertion sort, and that means that our thing will for sure be sorted all the way. All right. Skip the code in a second. In the middle, basically this h over 3, that's your division operation to narrow down the gap, narrow down the gap, narrow down the gap. The 1 here is actually basically to help with rounding. What will happen is, right, is this h value basically will trace all of these over here, right? So it'll go 121, 40, 13, 4, 1. All right. So inside we have just insertion sort, and it's insertion sort with a couple of changes here, namely, right, this bit over here. Well, okay, these are all the changes. The one that matters is the ones that matter are these. These 3 that I've underlined. Notice basically that when we do a less operation, we're checking j against j minus h. And then we're doing exchange with j versus j minus h, right? So instead of -1, right, instead of comparing the neighbors or exchanging with the neighbors, we're exchanging it with k elements away, right? So that's the big difference there. Because normally, right, this would be j minus 1 if you were in the insertion sort. But here we're not in insertion sort, we're in shell sort, and so that h is there. It symbolically lets us have that gap where we're comparing something far away. And then everything else kind of follows from that, right? So the fact that we're moving, h elements, right, is kind of coming from the fact that we're comparing, right? We're comparing h elements away, so then when we want to move, we should move h elements away as well. So those 2 things are all kind of coming together. Insertion sort, right, basically all these values are going to be 1. Here for us, right, it's at h value. So yeah, and then to answer this question here on the slide, if h equals 1, you literally just get insertion sort. So feel free. If you want, what you can do is pick h equal 1 and then try rewriting the code yourself, and you'll see that you basically just get insertion sort back out. It's going to be the exact thing. So yeah. So yeah, this is the code, right? So again, the idea is you pick this H value, which is your maximum gap size, start kind of going through, doing your sorts, narrow that value down, right, until you get to 1, then you just run search and sort, and then you know it's sorted, and then you're done. So there you go, quick overview of the source code for Shellsort.